Hello everyone. Today we're going to go and check out Hyper-V networks and how they actually work and how we can configure them. We need to look at the three networks that we can create in Hyper-V. That's an internal network, an external network, and a private network. Now the private network is for computers to talk to each other that don't need to talk to anybody else inside the environment. The external network is so that our virtual machines that are running can actually act just like normal servers on the network and receive an IP address from other things on the network. And an internal network allows us to segment our virtual machines behind NAT, or network address translation. So let's get straight into the whiteboard and have an explanation about what all those three things are. So if you've got a Hyper-V server, let's draw a nice big box here, and let's call this our Hyper-V server. So this thing might be running, for example, Windows Server 2025, and you've installed Hyper-V on that Windows Server 2025 and you're ready to kind of get going. Now, this server is going to have a network card attached to it. This could be a physical server. This could actually be a virtual server in Azure as well. So this is going to have a NIC, or a network interface card, attached to this machine. This is going to be plugged into the wider network. So that's either going to be like your network, or if you're in kind of like Azure land, or if you're in like AWS land, that's going to be the main sort of management network of that infrastructure. So that's going to be connected to some sort of switch. Okay. And we're going to have an IP address. So for example, the IP address of that NIC might be something like 10.10.10.100. I'm being very simple with the IP addresses, but that's perfectly fine. And this might then actually allow us to communicate out to the big wider world, the big wobby on the internet. There might be a router that actually goes out to the internet itself. Now, if you're doing this at home, your router and your switch will kind of be the same thing, okay? But if you have a larger network at home, you might have your separate router and a separate switch. Either way, it's perfectly fine. Now, on Hyper-V itself, you've got three different types of network you can actually create. You can create an external network. You can create an internal network, and you can also create a private network. And each of these are known as a switch. So an external virtual switch, an internal virtual switch, or a private virtual switch. So if we start off with a private virtual switch, what does that mean? Well, if I go and create a private virtual switch in my environment, my virtual machines can connect to that. So if I've got, for example, a VM called VM1 and another VM called VM2, these virtual machines can connect to this private switch. Each of these virtual machines then has the ability to talk to each other over that private switch. But importantly, they can't talk to the outside world. They can't get over here and talk to the outside world. That's not going to happen because the private switch is not actually connected to anything. Okay? So to facilitate that, there's a couple of different ways of accomplishing this process. If it's a private switch like this, these could be, for example, on a completely different IP address range. It doesn't matter, there's no interactivity with this from the outside world. But what about if we wanted these virtual machines to basically exist as if they are more physical computers hooked up to a switch inside the environment? So we can kind of see them as normal computers. Well, we don't need to create a private switch. What we actually need to do there is we need to create an external switch. Now, when you create an external switch, and I'll show you how to do this in a minute. When you create an external switch inside Hyper-V, what that will do is it will hook and connect to this virtual NIC over here. And by connecting to this virtual NIC over here, it gives it a path to the outside world. So these machines can now actually have the same IP address ranges, so something like 10.10.10.101 and 10.10.10.102 as the host machine, because these are going to be treated just like machines that exist on the network itself. Okay, that's cool, but maybe we wanted to kind of isolate our network and also have the ability to kind of connect to the internet. Well, we can do that too. We can do one of these internal switches. And internal switches does something called NATing, or network address translation. So let's just explain network address translation first. So we'll scroll up from this diagram and we'll come back to this in a second. Imagine at home, okay, you have your router at home and your router is connected out to the internet, the big wobby over here, right? Now, when your router connects to the internet, your router is going to have a public IP address. Now, a public IP address is an IP address that is valid on the internet. So other people can connect to that router and that router can connect out to, well, everybody else on the internet. But that public IP address we need to share between our multiple different devices. So for example, you might have your iPhone plugged in. You might have, your computer plugged in, your tablet, your lights, whatever else you've got. Because in most modern networks, your router actually also acts as other things, okay? Or at least modern home networks. Your router might act as a Wi-Fi access point. Your router might also have a few ports on the back to act as a switch. And when these things like your iPhone and your computer actually communicate in your network, your router is going to do a couple of things. One of the things it might do, and probably does do, is do DHCP, Dynamic Host Configuration Protocol. What that means is it will automatically give IP addresses to the devices in your network. So for example, your router might say, okay, this computer, you get 192.168.0.10. And maybe this iPhone, you get 192.168.0.11. Okay, this is normally a pretty familiar range for a lot of people that have a home router and things running in their house. Now, what this is also doing is it's also doing something called NATing, okay? Or NAT is network. Let's draw this out. Network, carefully. Address translation, okay? Network address translation. And what this is going to do is it means that if, for example, this computer goes and accesses Google, okay, it will create a packet of data to say, I want to go to Google. That packet of data will flow. Let's go and select this actually. There we go. That packet of data will flow through your router, out through the big wide world, out to the Googles, okay? But here's the thing. That IP address down there, that 192.168.0.10 is not valid on the internet. So when this packet of data finally reaches the Googles, okay, Google need to know where to send information back to. And it only knows the public IP address of the router, that kind of front door into your environment. So what it will do is it will send a packet of data back addressed to this public IP address. But thankfully, this router has got NAT, network address translation, running on it. And NAT has remembered who sent that packet. So what it's going to do is it's going to send that packet down here and translate it from being a destination of a public IP address. It's translating it to put a different address on there, and that address is the internal address of the computer. Okay? Now we can take this same NAT logic here, and we can use this for internal networks on Hyper-V. So let's scroll down here and just take a look at this diagram again. If I get rid of this external thing in the middle over here, let's just rub some components out here. So let's get rid of this external, let's get rid of this link, let's get rid of these IP addresses. If I create this as an internal network, okay, an internal network, what's going to happen here is I can actually run a little bit of a PowerShell command. It's a PowerShell command called new netnat, okay? It's a bit weird. Just bear with me. Again, I'm going to demo this on Hyper-V in a minute. So hold up. We're going to see this. We're going to see this deployed in a second too. So you've got these two virtual machines created. We've got this internal network created. We're creating new netnat. What that means is we can actually give these virtual machines now completely different IP addresses manually. So like 172.16.0.11. and 0.10, and we can specify with this new we can specify with this new netnat command a gateway IP address. So something like, in this sense, 172.16.0.1. And our new netnat command is going to form a NAT connection between this internal network and this physical NIC here on this external system. So what that means is this now gives these virtual machines the ability to actually communicate to the outside world, but the outside world can't see these IP addresses. They only see this gateway IP address. This is a much more secure way of actually creating an internal network of virtual machines, rather than actually just putting them straight on the internal network itself. We're kind of segmenting that traffic away. It's especially useful if we're kind of running interesting test environments that we don't want to interact or overlap with our current live environments, but we still need internet access. So we can create that internal network with this new netnack command. So let's go over to Hyper-V and let's see what that kind of looks like. Okay then, so over here in the demo machine, we're going to start out with that private network. Now, I have downloaded on this computer the Windows Server 2025 ISO. I'm going to use that to install some virtual machines. But first, I'm over here in Hyper-V. And the first thing I'm going to want to do in Hyper-V, let's make that a little bit bigger, is I want to go and click on this Virtual Switch Manager. If I click on Virtual Switch Manager, this is where I can create my virtual switches. Notice I've got these three options: external, internal, and private. And I'm going to choose private for the moment. So let's create a virtual switch here. We can call this whatever we want, but I'm just going to call this private. And notice this is still selected here on private network on the connection type. I don't have the ability to do VLAN IDs. I don't need to. It's a private network. It's completely isolated. So let's just go and apply that. And let's go and click OK. Right, that's all done. Now I can start to create my virtual machines. Now, if you want to create virtual machines in Hyper-V, there's a couple of different ways of actually doing it and things you need to know about. So if I press new on my virtual machines here, notice I've got virtual machine, virtual hard disk, and floppy disk. Okay, let's make a virtual machine. Now, when we go and create a virtual machine, we get this nice little wizard and we're given a few options. I want to name this virtual machine VM1. I'm going to be very inventive with my names at the moment. And notice I have this location of CVMs to store the virtual machines. Now, before I do this, I need to drop out a second. I need to go into Hyper-V settings, because in Hyper-V settings, there are these two locations: virtual hard disks, which are the virtual hard disks that will connect to our virtual machine, and the virtual machine's location. Hyper-V puts these in two different locations by default, and it actually puts in a really, really long path. So one of the things you want to do on your Hyper-V environments is come in here into the Hyper-V settings and just change these to a path that kind of make a little bit more sense. So let's go new virtual machine, and we're going to call that again VM1. That's going to be stored in that CVM's location. That's great. That's exactly where I want it to be for the moment. Let's go next on this. And let's go and deploy this as a Generation 1 or Generation 2 virtual machine. Now, what's the difference here? Well, with the Generation 1 virtual machine, this is virtual BIOS. Okay, this is like old style virtual machines. So with virtual BIOS, we can actually have virtual floppy drives and virtual IDE controllers here. Generation 2 virtual machines are newer. These support the VHDX hard drive format. And also these virtual machines for Generation 2 are virtual UEFI rather than BIOS. This means they only support SCSI. So you can't have a virtual floppy drive on here, but this is the format that I'm going to take because I'm going to need that UEFI to be able to get Windows Server 2025 running. So let's go next on that one. We'll leave this as 4 gigs worth of RAM. That's perfectly fine. And when I come to the connection, I'm going to make sure to connect this to my private network. So let's hook that in here. It's going to create a virtual hard disk for this automatically. This is a dynamically expanding virtual hard disk. So even though that says 127 gig, it's not going to take up 127 gig on my hard drive. It's going to take a very small amount of space, and it's going to be able to expand up to 127 gig. That's perfectly fine for what I want to do. I want to attach an ISO to this, so let's go to Browse and let's go into our downloads over here and let's go and grab that ISO image for Windows Server 2025. Let's go next on this one and finish. Okay, that's created the new virtual machine now for me, and I can go and start this. If I right click on the virtual machine and click connect, you'll bring up this lovely little box here where I can actually turn this on. But one of the things I want to do or check is that this virtual machine, when I turn it on, is going to boot into the Windows Server 2025 ISO and start installing the operating system. So to do that, I'm going to go into File and Settings here, and let's just go and check this firmware location. And we can see the DVD drive is set to boot first before the network adapter and before the hard drive. That's great. We can carry on. So now if I start this, hopefully this should start booting into Windows Server 2025. Excellent. So now I'm going to go through this process to install this operating system. It's going to take a while, and we're also going to actually go and install this a second time to get a VM2 so we can actually see what the connections are like between those two computers. Let's leave this on US keyboard settings for the moment. And we're just going to install Windows Server. I agree to everything, that's fine. This is an evaluation. So we'll leave that to get this going. We're going to choose Windows Server 2025 Standard Edition Desktop Experience, not do this through Core. And yep, I'm going to agree to the license agreement. That's cool. Obviously, I've read the license agreement in detail in the past. I'm sure you guys believe me. And I'm going to use the entire hard drive here. So next on that one too. Wait a little bit again, and now we can install that Windows Server here. Now, while that's doing that on VM1, let's go and make another virtual machine. So we can do two things at once here. We can get both going at the same time. So to make a new virtual machine, same process. We're going to call this VM2. Same location to store it in, generation 2, same generation, same memory, and we're connecting it to the same private network, just like we saw in the diagram. So again, VM2 virtual hard drive, install an operating system, select an ISO image file, and we're going to select that same image file. It's going to be reading it twice for two virtual machines at the same time, but that's perfectly fine. This is virtualization, so it's perfectly possible. Let's go and have a look at the settings and check that boot order. Again, the boot order is coming from the DVD drive. Great, it's going to hit that first. Let's go and start this, and let's go and connect to this. And you can see VM1 is still running here in the background, still quite happily installing Windows Server. Oh, it looks like I didn't get to the any key in time here. I'm going to have to just restart that very quickly. You've got to get to that any key. You've got to click in with the left mouse button and whack the any key quite quickly. Otherwise, you're not going to be able to catch it. Let's just turn it off and turn it back on again. There we go. Right, awesome. So this is now actually going to boot into Windows Setup, and again you're going to see exactly the same thing because it's exactly the same OS. So let's wait for that Hyper-V machine to start. English United States, that's fine. I am an English UK guy, to be honest. Colour has a U in it, but for the moment, for the demo, we'll stick with English United States. So we'll use Standard Edition Desktop Experience, click Next on that one. Again, we'll agree to the terms, that's all cool. Searching for disks, wait for it to detect the disk. We'll use the entire hard drive, wait for this, and we will install Windows Server now. So we'll just wait for both of those servers to actually complete, and once they're done, we can come back and we can go and see what we can do with IP addresses on those servers and how it compares to what we've actually got running on the host machine that's running Hyper-V to see how our private network is running. Okay, so we now have two servers, VM1 and VM2. And if we just go and check these servers, have a look at the settings, you'll notice they're both, there's VM2, connected to private network, and VM1, if we go and have a look at that and have a look at the settings, is also connected to the private network virtual switch. Now, let's go and have a look at command prompt on each of these machines and go and check out the IP addressing on each computer. So if I do an IP config on this machine and an IP config on this machine, you'll notice they've both got 169.254 addresses. Because this is a self-assigned IP address, it's not connected to any other network, it's completely isolated. Now, let's see if we can communicate between each of these computers. So I have this IP address of 169.254.248.163, and if I go and ping 169.254.248.163, this is not actually going to work. That's because Windows Server by default is blocking pings. Let's just go sort that out. Okay, so since ICMP ping is blocked going from this computer here to this computer here, what I'm going to do is I'm going to just pop a quick firewall rule into this computer to enable IPv4. Now I did that with PowerShell, so you can see here there's a new net firewall rule with the name of ICMPv4, and this is actually going to allow a direction of inbound with an allow the protocol ICMPv4, and that's nicely applied to the internal firewall of this Server 2025 machine. Now if I rerun my ping over here, you should see that I actually have a ping. So we can see that I actually have connection between these two machines over a private network, but it can't communicate to the host machine or out to the wider world. So let's get on with having a look at what an internal network actually looks like in this scenario. So back over here in Hyper-V, I'm going to pop into Virtual Switch Manager and I'm going to create a new internal switch. Now when I create this new internal switch, I can just hit apply. We can change the name actually. We don't want that to be called new switch. We'll call this internal. Okay, let's go and apply that. Now, I can change these machines here, VM1 and VM2, to actually go and talk to this internal switch. So let's do that right now. Let's just change those switches that they're actually connected to. So we'll do this onto VM2 as well. Awesome. Now, this still won't do anything to the IP addresses because remember, this internal virtual switch only has communication to the host, and it's the host that is going to NAT that connection out to somewhere else. So what I really want to do is I want to give these things IP addresses in these machines, is give them IP addresses in a different range to the host, but do it in a valid range. So not the APIPA range, because the APIPA range is not designed to NAT, it's not designed to actually route to anywhere. So we'll just have a look at the host very quickly, and we can see that what I've got is 10.0.0.4 and I've got 10.0.0.1 as my default gateway. That's fine at the moment. So what I want to do is I want to pop over here and I want to just change these IP addresses around. So what I'm going to do is I'm going to come into each of these machines now and I'm going to go and look for network connections. So we're going to view network connections over here. We'll do the same on this side. Network connections. Whoops, it helps if I can spell. Network connections, view network connections, wonderful. And we're going to go to the properties of each of these. Then we're going to go and pop into TCP IPv4 and we're going to change the IP addresses. We're going to use a 172.160 range, I think, just to keep it nice. We'll set the default gateway to 172.160.1 and we'll set the preferred DNS server to 888. And we'll do the same on the other side here. We will obtain a following IP address, 172.160.0.11, and the subnet mask of 255.255.0.0. Great, 172.160.1, the preferred DNS server of 8888. Wonderful. So let's go and OK both of those and close those off. Those are now ready to be able to communicate to my host system. So there's something else I need to do to the host system. Okay, so the next step of the equation is to get traffic from here out to the internet. So we need to just check I've got internet access here. So yes, okay, that's great. I've got internet access on the host machine. Now I'm going to need to do a little bit of PowerShell trickery here to make this actually work. So we're going to run PowerShell as administrator. And we need to redirect this traffic through the host machine. So to do that, the first thing I need to do is I need to run a get-net adapter. Okay, so running get-net adapter is going to show me all of the actual adapters that are attached to this computer. So I've got a couple. I've got a VNet internal. Okay, I've got the Ethernet switch over here and the Ethernet 5 switch over here. So what I need to do is I need to get this Hyper-V virtual network adapter, the one that's connected to my internal switch, and check the IF index for that. So the IF index for this is 8. This is the number of this actual card. So I can identify the card through its name, but I can also identify it through its number. So what I need to do now is I need to do a new net IP address. Okay, what this is going to do is this is going to perform the NATing operations from the internal network to the outside world. And what I'm going to use is I'm going to use the IP address that's at the start of the range that I set on the internal machines. If you remember, I set 172.16.0.10 and 0.11 on the internal machines. So what I'm going to use is 172.16.0.1, which is going to be the gateway of the internal computers, or actually inside the virtual machines. We need to give a prefix length, which is the length of the amount of binary bits that make up the subnet for that. So this is 255.255.0.0, so that's going to be 16 for us. And this is going to route through the interface index of index 8 over here. Okay, we're going to run that, and that's going to create our net IP addresses down here. So now what we can do is we can do our new dash netnat, and this is the magic command that we actually need. And we're going to give a name for this new netnat, and we're going to call this just nat. Okay, network address translation, it doesn't matter. And we're going to make sure this has actually got an internal, not the internal routing domain IP address, the internal IP interface address prefix, and that's going to be 172.168.0.0/16 on here. So running that, now we should be configured. Those two magic commands, the internal net IP address and new dash netnat. Okay, so we now should be all nicely configured. And if I go back to my virtual machines, like my VM1 over here, let's keep our fingers crossed and see if that actually works. So I should have inside VM1 an IP address within that 172.168 range and the ability to communicate to the outside world through that internal switch and through that NAT. But it does mean that things from the outside world can't communicate directly to this machine because it doesn't have an IP address in the ranges on the main management networks. So let's go check that out. Welcome to Microsoft Edge. Hey, there we go. We have internet access within our virtual machine 1, and we'll just check the IP address again. Do that, and let's do an IP config over here, and we can see that's still on 172.168.0.11. So that's the second way of setting things up. We looked at a private network, and now we've looked at an internal network. The final thing we're going to look at is an external network on Hyper-V, where these virtual machines are going to be directly connected to the same network that my host machine is connected to. So let's come back over here into Hyper-V Manager and go into Virtual Switch Manager. On here, I'm going to create an external switch. Now, when I do create this external switch, I'm going to need to make sure that this thing is connected to an appropriate external network. Now, for you, your external network here will actually normally show a physical network adapter, especially if you're doing this on your own computer. But for me, this here, and this host machine is actually a machine running in Azure. So I'm technically double and triple natting this as well. That's why I'm seeing a Microsoft Hyper-V network adapter here rather than a physical NIC, because this itself is a VM. So I'm going to just enable that here. It says pending changes may disrupt your network connectivity, which it will do. This will lag for a moment as it actually kind of crunches through and creates that external network for me. So let's just wait for that to complete and come straight back to it. So the external switch. In Virtual Switch Manager, I have that external switch created, and I've got this allow management operating system to share this network adapter. That's perfectly fine at the moment. Something you have to do to make sure this is actually going to work correctly is if you come into your network adapter, go into advanced features and enable MAC address spoofing. You need this if you're doing nested like I am at the moment. But I have a big problem. This is running on Azure. So this host machine here is running on Azure, and this virtual machine is running on top of that host machine. In a normal organization right now, this network adapter, if I go into the status of it and the details, would pick up an IP address from the same network that the host is on, because this is a bridged connection into that network. But because I'm on Azure, that's not going to work. So let's go over the whiteboard and see why. So if you're trying to replicate this in Azure, let's think first about on-site. Okay, so on-site, what we've actually got is we've got our Hyper-V host, all right? We've got our host machine, and this thing is running Hyper-V. And inside there, I've got my virtual machines. I have my VM1 and I have my VM2, just like we were working with a moment ago. And what's going to happen is these VM1s and VM2s are going to be connected to that switch, that external switch that we created. So these NICs, network cards, are connected to the switch. And this switch is actually going to be connected through the physical NIC of this machine. And this NIC is going to be connected into a physical switch and off into the regular network that this is actually kind of working on. Now, what's needed to happen at this point is these machines will need to pick up some DHCP. Now, there will be a DHCP server somewhere inside your network. The problem here is that Azure, and doing this in Azure, doesn't support layer 2 networking from the actual management plane. This here would be Azure's management plane that you can't see, that's managed by Microsoft, and the internal networks over here running inside VM1 and VM2. It's only going to support that networking to the host itself. So if you are doing this functionality on Azure, you are going to be limited to using that internal network that I talked about before. So just to refresh, you might have a VM1 and you might have a VM2 that's actually running inside of one of your Azure virtual machines, okay, that you've created. And what you'll need to do is make sure that these are connected to an internal switch, and that internal switch is going to be connected to a special NATing NIC that you create with that new netnat commands that I went through before with you. That's perfectly fine as long as those VMs are on a completely separate network and they are natted before they actually end up going through the Azure management networks. Everything will be perfectly fine. But if you are doing it internally, you can use that on-site scenario and you don't have to worry about this problem at all. It will just work straight through and those VMs will appear as if they are VMs on your network. So that kind of concludes looking at the 3 different types of networking we can actually do in Hyper-V: private, internal, and external. Remember, there are some limitations if you're trying to do nested machines inside Azure for external, but internal and private work perfectly fine. Okay guys, so I hope you enjoyed that demo for Hyper-V, and you'll join me next time for some more Azure Server Infrastructure tutorials and Microsoft Windows Server 2025 tutorials. Have a good day.
And you know the routine, hashtag like and subscribe, and I hope you enjoyed this video and will join me next time. Goodbye.